You are listening to The Vocal Technologist. Spoken tech for your ears.
If you feel like you need a crash helmet just to keep up with the technology news this week, you are definitely not alone.
Oh, absolutely.
Everything from the software development pipeline to, the literal orbit of the planet is in high-speed transition.
It is.
It's no longer just an evolution we're observing. It feels like an acceleration across every single front, strategic, infrastructural, and, regulatory.
That velocity is, it's unprecedented. It's forcing these huge course corrections almost daily, whether we're talking about model design inside a Silicon Valley bunker or, how we're building power plants in Denver.
Exactly. The foundational layers are all being overhauled at the same time.
At the same time.
So our mission today is to cut through that information overload and really zero in on the key strategic shifts. We're going to look at what the model giants are doing, how the infrastructure battle is moving into space, and what that all means for you.
For the future of coding and autonomy.
Okay, let's unpack this. So first up, the battle royale among the large language model makers, it just continues to define everything.
It really does.
And I think the biggest signal this week has to be OpenAI initiating what Sam Altman called a code red.
Yeah.
He didn't just send a memo, he paused all non-essential side projects for 8 weeks. The entire company focused strictly on boosting ChatGPT's core performance.
It was a very aggressive move. It shows that even with their market position, they feel immense pressure. They shifted from, long-term research, the stuff that grabs headlines, to immediate practical gains.
And we are already seeing the results of that sprint.
Instantly.
They just released GPT-5.2. It comes in 3 variants, Instant, Thinking, and Pro. But the big headline upgrade here is huge.
Oh, the context window.
A massive 400,000 token context window, and its knowledge cutoff is now August 31st.
And that context window is it's truly transformative. We need to really understand why. It's not just more memory.
Right.
A context window that size allows the model to ingest and manage an entire complex code base, or an entire novel, or hundreds of pages of legal contracts.
All at once.
All at once, simultaneously. This fundamentally shifts the types of tasks companies can use it for.
So it moves from helping you write an email to digesting every single document related to a major acquisition.
Exactly. That's what they mean by unlocking more economic value for people.
And it's their 3rd major release since August. It just shows that speed is their main defense right now.
Precisely. They're setting a pace that competitors are just struggling to match. It's worth noting, though, they are keeping GPT 5.1 around for paid users for 3 more months.
Gives enterprises some time to migrate, which is smart.
A little breathing room.
Okay, so meanwhile, Google is preparing its next major salvo. And it's focused less on the chat box and more on, changing how we use the web itself.
Yeah, I'm talking about Google Labs' experimental Disco browser.
This feels like a deep structural challenge to the browser as we know it.
It is. Disco's core feature is something called a GenTab, and it's powered by Gemini 3. It's not just summarizing web pages. It's designed to build interactive web apps right inside the browser.
To help you complete tasks.
Complex, multi-step tasks.
Yeah.
Things that would normally require you to jump between, 5 different websites and apps.
And the really clever bit, the thing that I think positions this for the future, is its ability to analyze your open tabs.
And your chat history.
And your chat history to select the exact right tool or piece of information for a prompt. It gets your entire context.
Yes, and this is where the trust part comes in. The critical promise they're making is transparency. Every single generative element in Disco, it ties back to the web. It links to the original content.
So they're signaling that this deeply integrated generative component is the future for Chrome.
I think so. Not just search, but task completion.
Speaking of core functionality and, intellectual property, we have to talk about how the big IP holders are reacting.
Disney deal.
Disney just invested $1 billion in OpenAI, and that's tied to a 3-year licensing deal. That's a massive vote of confidence.
It's more than that. I think it's a blueprint for the future of media licensing.
What does it mean in practice?
Well, it means OpenAI users will get licensed access to generate videos featuring Disney characters, probably through models like Sora.
Which opens up entirely new creative pipelines for advertising, for short-form content.
Fan-based experiences, you name it.
But, the agreement must have some incredibly strict rules about character usage. I can't imagine Disney letting Mickey do anything that tarnishes the brand.
Oh, you'd be right. The agreement has very specific provisions that place strict limits on the actions and scenarios their characters can be put in.
It's a tightrope walk.
It is. It highlights this complex balance between, unprecedented creative access and the ironclad protection of IP rights.
And that creative demand for hyper-realistic content, whether
Yeah.
it's a Disney ad or a complex simulation, that requires just astronomical amounts of compute power.
Exactly. And that demand signal shifts the whole strategic battlefield from software to, well, to physics.
Right.
We're seeing a new space race emerge. You have companies like SpaceX, Blue Origin, even Google, all trying to bring data centers into orbit.
The idea sounds like total sci-fi, but the challenges are just immense. You're talking about managing hardware temperatures in a vacuum,
Sure.
protecting servers from space radiation, and then, the big one, getting the data back to Earth without crippling lag.
Those hurdles are absolutely real, but the technical feasibility, that's not in doubt anymore.
Okay.
The NVIDIA-backed startup, StarCloud, is running Google's Gemma LLM in orbit right now,
As we speak.
as we speak, on a satellite with an NVIDIA H100 GPU. So that's proof positive that this can work outside of a terrestrial environment.
But I did read this skeptical viewpoint, and it's pretty compelling. You might need tens of thousands of satellites just to match the compute of 1 gigawatt data center on Earth.
Right.
So why bother? Why the incredible complexity and cost?
That's a great question, and it gets to the strategy. Orbit isn't just about matching what we have on the ground. It's about two critical things. Low latency edge computing for global operations.
Like remote sensing or military apps.
Exactly. And crucially, regulatory bypass. Building in orbit lets a company get around terrestrial power grids, land costs, and all these evolving data sovereignty laws. It's the strategic high ground.
Not just a cooler place for servers.
Not at all.
A strategic high ground that needs massive amounts of power here or there, and this AI boom is creating this insatiable hunger for energy.
And that brings us to a company called Superpower. This isn't just an off-the-shelf generator. It's a 42-megawatt natural gas turbine that's been optimized specifically for the high-load demands of AI data centers. And it's built by Boom Supersonic.
And the scale of the launch is breathtaking.
It is. They already have a 1.21 gigawatt launch order from a company called Crusoe.
That's a massive commitment.
It's huge. And Boom is responding by building a new super factory in Denver just to produce 2 gigawatts of these turbines per year. It just shows the scale of the investment required to keep the AI lights on.
And while some are building specialized power plants, others are using AI to find cleaner power sources. Zanskar, for example.
Right, they're using advanced AI models to prospect for new geothermal sites.
And it's working.
It's proving highly effective. Their models can identify these subsurface heat signatures. They recently found a massive underground heat source in western Nevada.
Wow.
Geothermal was historically so hard because finding those viable heat sources was like, a needle in a haystack. AI prospecting seems to be a genuine game changer here.
Okay, so moving from the literal foundation of power to the foundation of the digital world, software development, let's ask that provocative question. Has the cost of building software just dropped by 90%?
That estimate, it reflects a true seismic shift.
Yeah.
And it's driven almost entirely by the maturity of agentic coding.
So the old ideas that LLMs make too many mistakes or they can't grasp a complex code base, that's all out the window.
It's being proven false very, very quickly. The technology is just transforming the entire development lifecycle.
Traditionally, every new feature you added made the next one harder. More edge cases, more dependencies.
More technical debt. It was a compounding liability.
Right.
Compound engineering flips that script completely. It creates a learning loop for the AI agents. So instead of a liability, the code base becomes a compounding asset.
Oh, so?
Every bug, every failed test, every architectural insight the agents gain gets meticulously documented and fed back into its own knowledge. The AI's understanding of the code base grows with the code base.
So future development gets faster, not slower.
Exactly. It's continuous self-improvement built right into the DevOps process.
That structural change means the most valuable person in the worm is shifting from the legendary 10x coder to someone you call the 0.1x engineer.
Precisely. The 10x engineer's value was all about output speed. The 0.1x engineer's value is about quality and curation.
So their job isn't to just prompt an assistant to add another 1,000 lines of code.
No, not at all. It's about architectural review, setting the right guardrails, and telling the difference between bloat or LLM slop leftovers and genuinely useful, maintainable code. They manage the quality.
That shift in value, where curation becomes more important than raw output, is exactly the kind of deep thinking we love discussing here on The Vocal Technologist.
And this leads directly to how corporations have to adapt. The companies succeeding here are the ones adopting a model weight first approach.
What does that mean?
They don't try to force the AI to rigidly adhere to pre-existing corporate dogma or old engineering principles. They work with the technology's natural cadence.
And the companies that are struggling are trying to bend the tech to their will.
Exactly, which leads to lower productivity, and they fail to capitalize on the velocity that agentic coding gives them.
All right, let's pivot to autonomy. It is advancing at just breakneck speed across multiple fronts, making the whole competitive field incredibly interesting to watch.
The landscape in autonomous driving has never been more segmented. You look at Rivian, they're developing custom chips, proprietary AI, and they're planning a subscription service for early 2026.
And their near future update is this universal hands-free driving.
On over 3.5 million miles of North American roads. So they're focused on a very measured, verifiable rollout.
Then you have Tesla, which is maintaining its, let's call it an aggressive timeline.
To say the least.
CEO Elon Musk is now claiming that completely driverless robotaxis, so no human safety monitor in the passenger seat, will be operating in Austin in about 3 weeks.
That is an extremely ambitious timeline. We'll be watching that one very closely.
And then meanwhile, Waymo just keeps widening its lead in commercial deployment.
Yeah, they just crossed 450,000 weekly paid rides. They've expanded into several major cities and debuted on freeways in 3 cities now. Their velocity in these dense urban areas shows a real operational lead.
Autonomy isn't just about cars, though. It's also about defensive tech.
Right.
And we saw some wild results from a cybersecurity test recently.
This was the test where Stanford's Artemis AI bot went head-to-head with professional human penetration testers.
And the AI basically won.
It surpassed almost all of them. It beat 9 out of 10 professionals, finding critical bugs at lightning speed for under $60 an hour.
Which sounds like a complete victory for the machines until you dig into the caveats.
Exactly. The AI had about an 18% false positive rate. And maybe more importantly, it missed one obvious, high-severity bug that the human testers caught immediately just by reading the documentation.
So what does that tell us?
It shows AI's incredible speed and efficiency at finding common flaws. But it still lacks that human intuition to step back, to understand context, or to, just read the manual.
Okay, finally, we have to look at how governments are trying to cope with all these changes. There's a major development in Australia that's setting a new global precedent.
A new law there now requires several social media platforms to shut down accounts for teens under 16. They're citing mental health risks.
And the platforms have to take reasonable steps to enforce this.
Under threat of penalty, yes.
What does reasonable steps even mean in this context? That sounds like a compliance nightmare.
It's a massive technical challenge. It relies heavily on age gating and maybe AI-driven age verification, which, has its own privacy issues.
And this isn't just an isolated thing.
Not at all. Other regions, the EU, Florida, Malaysia, New Zealand, they're all discussing similar restrictions. So it suggests a global trend toward mandated age verification on these platforms.
So, to recap, we've covered the code red scramble at OpenAI, the strategic race to put H100s in orbit, the structural collapse of software building costs, and cars driving themselves with no one inside.
It's a lot.
AI is accelerating everything, and it feels like governments are definitely playing catch-up. So what does this all mean for the broader strategic outlook?
It means the speed of change is immense. But that rapid change requires really critical, grounded thought about how we implement it.
Right.
A lot of the discourse around superintelligence and AGI, particularly coming out of, the Bay Area, can be a bit flawed. It's an echo chamber amplifying these abstract ideas, like focusing only on far future existential risk.
Without looking at the immediate impacts.
Exactly. Without the critical awareness of things like labor displacement or mass power consumption happening right now, we need realistic thought to shape a beneficial future.
That distinction between hype and practical application is so vital. And considering the rapid rise of agentic coding and this newfound value of the 0.1x engineer, if the cost of building software keeps plummeting, what specific human skills will never be outsourced to an agent? Where should you focus your learning next?
That's the question.
I think about curation, context, and quality control.
Indeed. Those who can navigate that interface between human needs and artificial intelligence, the architects, the curators, they're the ones whose value is going to appreciate the fastest.
Thanks for joining us for this in-depth exploration into the technology battlefield. We'll catch you next time.
Spoken Tech for your ears.